Hi, I'm Beth from my tutoring bee, and today we are talking about another kind of special right triangle. This time it is the 45, 45, 90 degree triangle. So let's get started. So I have a triangle drawn here. Let's go ahead and label the measurements of each of the angles. We can see that the 90-degree angle is already labeled right here. And then because this is a right isosceles triangle, that means that these two sides are congruent. This side is equal to this side. And with a right isosceles triangle, any right isosceles triangle, you will always have these measurements. You will have the 90-degree angle. That's what makes it a right triangle. Then you're going to have that these two angles are each going to be 45 degrees. So this one's 45 and this one's 45. Because we have an isosceles triangle, this is the nature of them, the rule of them, that because these two sides are equal, then the opposite angles of each of those two sides also have to be equal. And we know that the interior angles of a triangle all have to add up to 180. If we've already used 90 of those degrees here, then the remaining 90 must be split evenly amongst these two remaining angles, so that means they each have to be 45 degrees. So let's talk about the lengths of the sides of a 45, 45, 90 degree triangle. The rule is always going to be the same for any size 45, 45, 90 triangle. So that's where we're going to go through and use geometric proofs and Pythagorean theorem to show why these rules work. And then you can take that knowledge and apply it to any triangle that has any right isosceles triangle that is 90, 45, 45. Okay, so let's label these two sides. Remember, these two sides are congruent, they're the same. So let's give them the length of x. They both are x. And then by using the Pythagorean theorem, we can find this angle, or sorry, the length of the hypotenuse over here, which we will call c. Pythagorean theorem, as we know, is a squared plus b squared equals c squared. So we're going to take our measurements and substitute those into our theorem and come up with the length of C based on the length of our legs, or the x lengths. We know that these two lengths, the two x lengths, are going to be our A and B sides because they are the two sides that make up this 90-degree angle. So that's how you know that those are the A and B sides. And since they are both the same, we're just going to label each of them as a squared and b squared, or sorry, I shouldn't say label, I should say substitute them in for a squared and b squared. So now we've got x squared plus x squared, and that equals c squared. So let's simplify and see if we can figure out what this length would be. So when we simplify this side, we get x squared plus x squared. Well, that's 2x squared. And then we're just going to bring down our c squared. And then we need to find the principal root of each side. So we're going to take the square root of 2x squared and the square root of c squared because we want to find out what just c is by itself. So that's why we need the principal root there. So the principal root of 2, we're just going to leave as the square root of 2. And the principal root of x squared is just x. So we've got x times the square root of 2. And then that equals the principal root of c squared is going to be just c. So here we've already figured out that the length of c as it relates to the length of these other two sides of the triangle is just x times the square root of 2. So again, how do we apply that? What does that mean for other triangles? Well, if we are given a triangle and we are told that it is a 45, 45, 90 triangle and given just one side, one length of one of the sides of the triangles, we can figure out the other two sides by using these rules. So let's take a look at that. So here we have a 45, 45, 90 triangle. We can tell by looking at the angles that we can apply these new rules that we just learned to this triangle. We were only given that this side is equal to 4 units, and we want to find out the other two sides. So we can apply our special rules that we just figured out and I left our example over here for us to use. So if we know that this side is 4 units, then that means that this side is also 4 units. Because it's an isosceles triangle, it has to have two sides that are equal, and because this 45-degree angle corresponds to this length of 4, then that means this 45 angle also has to correspond to a length of 4. And then by using our rules, we don't even have to plug into Pythagorean theorem. We could if we wanted to, but by using our rules, we know that the hypotenuse is just going to be whatever the length of one of those sides is times the square root of 2. So the hypotenuse for this triangle is going to be 4 square roots of 2. So we've just solved and found out the length of the other two sides of this triangle. Even though it was rotated around, it's oriented a little bit differently, but we can still apply those same rules. Here's another example for you. Again, the triangle is rotated a little bit, but we can still see that it is a 45, 45, 90-degree triangle. And this time we're given the hypotenuse, and we're told that the hypotenuse equals 2. So let's see if we can use our special triangle rules that we just figured out to figure out what the lengths of the other two sides are. So we know that this is the hypotenuse and that the two sides that are missing are the two equivalent sides or congruent sides. So let's see if we can apply our special rules. So we know that the hypotenuse is normally x times the square root of 2. And whatever that x is would have to be the same for each of these two sides, the two legs of the triangles. So let's think here, what could we plug in here? What could we substitute in here for x? Then when we multiply it times the square root of 2, it equals 2. So if you said the square root of 2, then you're right. So if we do the square root of 2 times the square root of 2, that gives us 2, which is our C, or our hypotenuse of this special triangle. So then that means our x value has to be the square root of 2, meaning that our legs over here are each the square root of 2. So I hope this video was helpful for you in learning about special right triangles, particularly 45, 45, 90-degree triangles. You can apply these special rules to any 45, 45, 90-degree triangle that you come across. And please don't forget to like and subscribe, and thanks so much for watching.